Hello, everyone, and welcome to our webinar entitled NodeCom, Intelligent AI-Driven Predictive Maintenance and Asset Integrity Management Solution. On behalf of PCSS Consultancy, we are excited to have all of you today as we dive into today's webinar. My name is Angelina, and I will be your host for this afternoon session. Now, before we begin, let's go over a few housekeeping details to ensure a smooth and engaging webinar experience for everyone. This webinar is being recorded and will be available on our official YouTube channel. So please check us out. If you miss anything, you can revisit us later, and don't forget to subscribe. Secondly, please keep your microphones muted and to avoid background noise and ensure clear audio to everyone. As we highly encourage active involvement from our audience, please feel free to drop your questions in the chat box, and I will do my best to address them. Thirdly, QR code for the attendance and feedback will be shared at the end of the session. So please stay until the end so that you can scan it. Now, please allow me to briefly introduce on PCSS. PCSS is a premier project management solutions provider focused on enhancing organizational profits through the implementation of industry-leading practices. With expertise spanning from project management office, software training, integration planning, and team management, we want to ensure our clients to achieve sustained success in the project delivery. So backed by over 35 collective experience in project controls, we offer specialized solutions that elevate capabilities and maintain a competitive advantage. As a one-stop shop, PCSS is committed to meeting diverse project management needs. Moreover, we specialize in digital construction, covering BIM, simulation, 4D simulations, optimization of tools such as drones, AR, VR, to name a few. This emphasizes our dedication to staying technologically advanced and providing innovative solutions for the digital transformation of the industry in the region. With that said, we believe that we're set for an informative and engaging session. Ladies and gentlemen, it is with a great pleasure that I introduce our distinguished speaker for today's webinar, Dr. Shaktivell. Dr. Shaktivell is an innovator, researcher, and technopreneur behind Stratetics Experts Sri Berhad, a company driving AI-powered predictive maintenance, structural integrity assessment, and smart energy solutions. Being a mechanical engineering PhD holder from University Tun Hussein on Malaysia, Dr. Shaktivell founded Stratetics Experts as a student startup in 2022. Today, it leads in sustainable tech across oil and gas, EV charging, smart agriculture, and industrial AI solutions. With a strong focus on sustainability and a team that is made up of 90% of university students, Dr. Shaktivell is committed to empowering the next generation to build a greener, more energy efficient future. All right, to dive into today's topic more, I would like to pass the session to Dr. Shaktivell. So, Doctor, the floor is yours.
Yeah, thanks, Miss Angelina. Thank you so much for inviting me to share what does strategic experts do. Very good evening to all the audience. I guess my audience has different expertise, different level of expertise in their own sectors and industry. But I wish to share what we are developing from Stratetics as a student-based startup, now one of the preferred startup in the ecosystem as well. So before we dive in, I would like to share my screen Just a moment. And is my audio is okay? Fine.
Your
Yeah.
audio, I think it's a bit far from the from the microphone.
Okay, just a moment. Let me fix that. Just a moment. Okay, just a moment. Just a moment. So I wish to have my now it's okay, right? Clear? Is my audio clear now? Not so far?
Yes, it's better.
Okay. We can have our session to be interactive, and I prefer that more because I don't want like people just listen only. It's better to have an interactive session. So if you have any questions, you can just ask me uh, throughout the session, no problem. Or you can also ask the question relate at the end of the session as well. But prefer it to be during the session. Okay. So I guess I have a 1 hour session, 1 hour plus, if I'm not mistaken. Okay. So is my screen can be seen? Full screen?
Yes, yes, it's working.
Okay, great. Just play around. Yeah, okay, fine. So like how I introduce myself, I'm Dr. Shaktivell from Stratetics Experts in Hammerhead. We are a student-based startup. So purely we are dealing with a lot of things related to AI. And one of the industry that we are working into is constructions and so on, beyond oil and gas industry. So I basically have different roles in different sectors. So, but my PhD was in mechanical engineering. So this is my uh, company background where, like how I said, we are into oil and gas, EV charging, smart agriculture, even digital marketing as well. Because startup you need to sustain, right? So that's the way. So, but our whatever things that we're doing is purely related to IoT, AI, machine learning, cloud computing, and so on. So, like how I said, our vision of strategy experts is purely related to technology AI, but related to sustainability. We consider both technology and sustainability as our vision and mission to achieve our goals on making the existing industry to be high tech. Okay, this is our team. I proudly can say that mostly my team is from Borneo, particularly from Sarawak. So because I studied in UTHM, but Dominic, Sulfree, Dexter, all these people are from Sarawak as well. So I would say we are youngsters. We started very young on the solution, and now we are growing things. So all of us have their own expertise as well. All of us, I would say, we are less than. Seven of us actually less than 30 years old, including me. So my education background is I started as a diploma in mechanical engineering and degree in mechanical as well, masters also in mechanical and PhD. I graduated last year uh, in Doctor of Philosophy in Mechanical Engineering. My PhD is related to composite structures and simulating it with predictive model. Okay, so this is our structure of our company. We, like how I said, we are into oil and gas, smart farming, drone-based inspections, digital marketing, and EV charging station as well. So if you need anything related to any of these solutions, you can just refer to us. So, but I will be more emphasizing today related to oil and gas industry, particularly oil and gas plus structure related solutions, which is inclusive of inspectors solution as well. So without further ado, I would like to dive in into the topic today, which is intelligent AI-driven predictive maintenance and asset integrity management solutions as well. Okay, so like how I said earlier,
we are into this AI space, into industrial-based AI, where we develop the algorithm to do predictive maintenance and prescriptive maintenance. I would say it's a bunch. This project is a bunch of integrated solution in between AI, IoT, CAD simulations, NDT data, drone-related data, geospatial analytics as well. So we are trying to put it within a single window concept. For particularly, we started with oil and gas, and then now manufacturing industry, utilities, and infrastructure as well. Since my crowd is most of y'all are into constructions, so I will be just sharing my insights related to constructions. So whenever structure fails, the problem with current solutions, uh, it's not being detected at the early stage itself. Due to that, we lost in revenue as of now 30 billion per annum. So and 0% prescriptive maintenance in the sense of, yes, there are a lot of solutions out there that is really good, really being there, but prescribing in accordance to the problem of a structure, it has always have a gap, which is a mismatch, I would say. Traditional infrastructure maintenance rely on reactive and scheduled maintenance, and it just have a standardized specifications that already proven as it is, but making sure that is relevant for that particular problem is the biggest gap that we are trying to make. Without this particular solution into the perspective, this will lead to high operational costs, unplanned downtime, environmental and safety risks, and inefficient data collections and analysis. So we see that this is a problem that current industry, regardless it's oil and gas industry, regardless it's a construction industry, they face the same issues because due to the fact the solutions that exist in the market is because it's like they solve the problem at that moment temporarily, but not for a longer term. And that's where our .com solutions comes to the perspective. So we build in-house develop AI defect detection software. We use drone inspection services and other related inspection services, and we come out with professional inspection report as well. So how does the solution works? We go with macro level inspections where we use drones to do 3D drone mapping and geospatial AI data to detect the defects. So during micro level inspections, it will go through a series of analysis, which is with the 3D scanned data, we will start to do the defect detection that is being pre-programmed. From there, we will do the analysis and we will create a 3D model analysis for simulation set. From there, we will start with predictive model, AI-based structural integrity predictions, which has 10,000 of iterations of simulations. Now, most current, I would say, competitors are there at the predictive model, but prescribing in accordance to the predictions and the defects that has been identified earlier is the gap that we are trying to fill, where we prescribe the best solution that best suits the case at simulation stations using this predictive. From there, we identify the specifications of prescriptions with predictive analytics. Okay, I wish to stop here, and I wish to take any questions that is there. Is there any questions in the order? Yeah. No questions.
Not right now.
No, right now. Okay, so I'll just move forward. Now, I just want to show how does the overview looks like. Why we name it as inspector? Because we for this particular solution, we start with drone inspections. So with the existing software, we can see that once we do a mapping, we can see the integrated mapping of inspection footages within that particular window. From there, we'll do this 3D mapping, all these things to be there. And it will be inclusive of first level inspection, second level inspection as well. This will eventually give an advantage for us to see comparison in between the first level inspection and second level inspection. This is one of the solutions that we did, where it is a demolition demolition project, and the client wants us to check what is the problem. From there, we identify some of the defects within the building, and we start to do analysis, which is inclusive of stress distribution, all this carbon emission, all these things. So, and we also did some crack growth data, and we get to integrate it within our AI chatbot, which is, I would say, it is very, very late. I mean, it is in the early stage of that particular solution, because we are trying to gather more data from the industry to put within the AI chatbot as well. So, like how I said, we build a particular algorithm for oil and gas, solar, and so on. So this is one of the solutions that we also use for solar inspections as well. So upon we use for solar panels, defect detections, and so on, now we started to use in construction site, and I would show how does a construction AI defect detection looks like. Okay, just a moment. Huh? Okay. There should be. Okay. Okay, I hope you guys don't hear any music or anything. Right?
We can still hear the music.
Guys, with me?
Yeah.
Hello? Can you guys hear me?
Yeah, sure.
Okay, got it. So now, how does NodeCom feature works? It has AI-driven fault detection, automated reporting for quality check, performance analytics dashboard, predictive maintenance insight, multi-site management, cloud-based data access, GPS geotagging integration, which is to locate the defect, and to evaluate the project progress, monitoring and comparison, like how I showed earlier. And these are the sample analysis, I would say, which is inclusive of computation simulation. Of course, we started with oil and gas, so I just put a picture of it. But the important part is actually the analysis. Now, this is how the analysis looks like. Like how I said earlier, this particular structure needs the solution that can enhance the lifetime of that particular structures. So, like for an example, for the previous, uh, uh, I would say the analysis that we did, that particular building has cracks, and technically they are deploying glass fiber and carbon fiber as a wrapping structure of that structure to maintain the structure integrity. Now, what they ask us to do a 3D model of that particular pillars, and then they ask us to compare what is the specifications of the wrapper should be. Because all this while, what they have is a wrapper with the standardized data sheets. Now, the problem with that particular solution is how you know whether your 8 layers or 6 layers of composite wrapping structure is suitable for that particular case. That's where our solution comes into perspective, where with the 3D model analysis, defect detections, and so on that we did, we are able to simulate the particular wrapping structure whether it is in accordance to the structure's need or not. That's where we get to identify what is the maximum stress on repair section, minimum factor of safety of, we identify CFRP, carbon fiber reinforced polymer, as the wrapping structure that is suitable. But within this carbon fiber reinforced polymer, we are, I mean, in a normal technical way, they identify carbon fiber as a good material, but within the carbon fiber, they are not sure which particular layer is needed that can solve the problem. And that's where the solution comes into perspective. And from there, these are the sample, I would say, analysis that we did, which is inclusive of distribution of predicted structural lifetime of that particular structure and historical distribution of historic lifetime distribution through historic histogram based analysis as well. From the analysis, what we identified is this particular structure without the wrapper, it will lead to failure in 6.02 years, which is 6 years, I would say. This is the analysis that we did using the 3D model plus the simulations as well. From there, we get to see if with that crack, how long does that particular structure will bypass 80% of the threshold. So we are able to identify that within 6 years, it will reach the maximum defect threshold, but 80% is being simulated, which is 5.25 years. That's the threshold that we have so far done. So with the analysis that we have done, which is in the first stage, we use AI to identify the defects, and then we make it into a 3D model. We start to simulate, and we have started to do 10,000 of iterations. From the 10,000 iterations of predictions, we get to see this particular structure will fail in 5.25 years. Now, we need to take mitigation plan. So that's where the mitigation plan comes into perspective. Now, we know already for this crack, we need to use wrapping structure and so on. But within carbon fiber, glass fiber material, how we can justify whether which material to be used? Because for cheaper perspective, most of us, we will consider to use glass fiber. And most of us may consider carbon fiber for better durability. But the problem of identifying which particular material with which specifications is the question, I would say a question that need to be solved. And that's where NOTCOM comes into the perspective. So with the analysis that we have so far done, we're able to suggest the client saying that, okay, your structure will fail in 6 years. Now, from our analysis, we are able to identify that if you use glass fiber reinforced wrapper, technically your particular wrapping structure or structure will be in service for 10 years. If carbon fiber will be 12 years. Now, within glass fiber and carbon fiber, if let's say you decided to glass fiber, what would be the orientation? That are the specifications that we have so far identified through this particular solution as well. And from there, we are able to also identify what would be the crack growth rate with the consideration of that particular wrapping structure. So if let's say if you're using carbon fiber reinforced polymer with the specifications that we have so far identified, we can see that the crack growth will bypass 80% of the threshold after 8 years. This is carbon fiber. This is glass fiber. For carbon fiber, it is 11 years. It is an extended version. But for the structure that has that don't have any wrapping structure or anything, it will fail in 6 years. So from here, the justification can be done by the client to consider the wrapping structures that is needed for that particular case. Now, on the other perspective, this is able to this particular solution is also able to give a schedule maintenance perspective, because by identifying the severity of the defects within the structure, what will happen is technically we are able to sort out what are the defects that needs to get priority to do repair or inspections. We are able to give a schedule maintenance work as well. From there, they are able to identify whether which structure need to get a prior attention before getting into the small defects. I would say we are in a very early stage of doing. Okay, I guess I have a question now. How many times you will take picture of the crack for analysis? Do you take other variables such as grade of material and cost of crack defect into? Yes. Okay. So how many times as of now we have taken into the perspective, because once we identify the defect, then we take almost 12 times of that particular pictures to build the model, because AI is very flexible, whereby the more you feed the data, the smarter that particular defect can be identified. Okay, so it depends on the client as well. So if our current client, which is at Cyber, they asked us to take 12 times so that they are able to match with their 2D drawing that they already have. They wanted to see whether, okay, where within that particular site, where does the crack is happening, why, and so on. Point one. Second question is, do you take other variables such as grade of material? Yes, yes. We are at this point of time, we are just taking we get the standard data sheets from the client of, let's say, for a pillar, what is the specifications, column structures, what is the strength, and so on. We put it as part of the data, and we put it as our data input for to do the predictions as well. Did I answer the question? And yeah, cost of crack detection. Okay, cost of the crack detection. Yes, we are able to give, I would say, a general overview of that cost of crack detection, crack or defect, but we can't do precise. The reason why precise, we cannot give a precise cost is because the current AI is being built in a way to start to do the analysis, but the cost is highly dependent on the information that is given by the client. The current client that we have so far, they have given us an overview only. We didn't get a specific uh, detail of that particular site, due to, because this company also is a subcon of main con. So we already requested them, okay, now we already detect your defects, and also we give you the suggestions, but the cost is they have to give us what kind of informations that is able to give the defects cost as well. Okay. Any questions? Anyone want to ask questions? No? Yes? Okay, I go for the next slide. Okay. Now, what would be our unique selling point is, technically we will have a comprehensive system for inspection analysis, single window AI, finite element analysis, and inspection integrated software. Robust AI model that is able to do predictive and prescriptive maintenance, and scalable and customizable integrated solutions. This will lead to enhanced accuracy in defect detections and predictive maintenance, reduce downtime, environmental impact, which will reduce or prevent environmental excesses. Okay, I have another question. Based on the crack growth prediction graph, how does the AI model account for the sudden fluctuation of non-linear trends observed, especially in the without CFRP and with CFRP cases? And could this indicate a limitation in the mode's ability to handle real-world variability or environmental factors over time? Okay, good question. Okay. First, I try to break this question into two. Based on the crack growth prediction graph, how does the AI model account? Okay. Now, what will happen is the threshold that has been set yeah, I guess so. This is the slide that you are referring to. Now, what we will consult with the particular client is we will be asking them when does this particular failure could happen, and then we will see how many fluctuations are there as well. If it is more than 30% of fluctuations, and that's where we get the first red flag. And if it is beyond 50%, that's the second red flag. But some clients that we are currently working with, they are okay to have at least 30% and over. But even 50% also, they are still okay. But when they see that the crack is growing more than 80%, and that's the point where they started to ask us to set the threshold below than 80%. That's the point. And we see how many fluctuations are there happening on it. Okay. Okay, I guess I answered the first question. The second question is, especially without CFRP and with CFRP cases, and could this indicate a limitation in the model's ability to handle? Yes, I agree that this model has its limitations, because what at this point of time what we have is the materials data sets. Okay, material specifications, properties lah, I would say material properties of the composites in general, and another specifications is the pillars material that has been used, the ratio and so on. But we are looking ahead of bringing in the environmental parameters as well, especially the humidity, especially the corrosion rate over there. All these things will enhance the AI's capability to do the predictions. I don't say that that's why we always have within this AI ecosystem, I will always say that there is limitations for AI to do the analysis, because it is not considering all the particular environmental factors, but it's just purely on the data inputs. Yes? Questions? Okay. So just to continue the answer. Okay. Now, what we are trying to narrow the gap in between the AI defect detection analysis with the real world concept is, technically we are trying to bring in this weather forecast, all these existing parameters within the site, all these things to be a part of the predictive model that we have so far built. Okay. Did I answer the question, Mr. Zulfahmi?
Yes, doctor. Thank you very much.
Okay, got it. Okay. So now, in comparison with existing, I would say, solution provider, we are trying to not only get into predictive maintenance and so on, because I guess so, not guess what, I would say a lot of people have started to look into predictive maintenance, real-time monitoring, so on, even anomaly detections. But we are moving towards a prescriptive concept to be in related to predictive maintenance, so that we can narrow the gap. There are a lot of players that is able to provide predictive concept with all these particular features. But our strong area that we would like to focus is prescriptive maintenance with cloud-based simulations as well, so that we don't need to have multiple tools, but instead to check whether the structure or the entire project is doing well or not. We just need a single window that is accessible for the client as well. Okay, and this is what I wanted to achieve. Personally, I wanted to achieve, and as a company, we want to achieve as well. We want to look into single window approach, which is failure predictions, real-time condition monitoring, AI-based predictive model, digital twin concept as well. And to narrow the gap, which is prescriptive maintenance, maintenance action recommendation, root cause analysis, scenario-based decision support, and automated scheduling. Okay. So any questions for this? No? Yes? Okay. I'll just move to another slide. So after this will be, that's the overview of the solution as well. Now, we are looking into business perspective as well. With this particular solution on board to the client and so on, how we are going to generate money technically with this particular solution is by subscription plans, data analytics services, equipment sales, consulting services, licensing partnerships, and API integrations. Actually, we are open for collaborations as well. We are looking for more companies to work with us to give the data for us to do the analysis and so on, so that we can enhance the structural integrity predictions of either constructions or oil and gas industry, so that we can enhance the AI model instead of just have a pre-programmed model. Okay, and we are looking into service distribution within Malaysia, ASEAN, China, and so on, global expansion and collaborations as well. Where we stand is we started the I would say the research in 2022. Our main focus was actually composites at the first stage, because we know that the solution is good, but the relevancy of that particular solution for the structure gave us a gap that we need to give us an indication that there is a gap that we need to solve first before prescribing in accordance with the composite wrapping structures. So we started to validate the research, and then we start to build the AI since 2023, and we started to get a lot of defects. We trained the model and so on. Now we are in the stage of commercializing the predictive maintenance solutions. POCs is done. Now we are looking forward to push this particular solution to the industry, and after this will be related to robotics and so on. Okay, now where we stand, we are not, like how I said, we are not, this particular solution is not only limited to construction only or marine structure. We are also working on marine structure inspection, oil and gas industry particularly, because that's the core that we started, and also solar based inspections and solar panel inspections and aircraft maintenance as well. To make it very, very simple, wherever there is a problem in the structure, this particular AI that we are trying to build as an enhanced version, it should have that ability to adapt to the industry, regardless whatever industry, because the AI has been designed in a way to have an algorithm that is able to adopt all the data input that is already exists in the industry, and also start to predict in accordance to the standard data that is already within the ecosystem. We are trying to merge both. So if it is aircraft related or aircraft related structural issue, we just need some inputs so that we can start to do the predictions. Construction also same, marine structure also same, oil and gas also same, solar inspection also same. And particularly for oil and gas, we have started to work on breaking the ground penetrating radar frequency, so that we are able to identify the defect even if the pipe is it is an underground pipe and so on. Okay, and for this is one of our project that we did with the same AI that we developed. We initially pivoted to solar panel inspections at my university as well. From there, we got into now we are actually, to be very honest, compared to construction, solar farms have started to engage with us to start to fly drones within their particular solar farms to identify the defects as well, and it should be in accordance to the standards that has been provided, IEC standards and so on. I just want to remind over here the algorithm that we built for the oil and gas industry, for constructions and so on, still the same for solar farm inspections. Like how I said, this solution is very flexible to be adopted to different other industry. And this is another pilot project that we did earlier at Melaka. And this is a marine structure. This is a very interesting inspections that we did, particularly at Straits of Malacca, where this particular structure, marine structure, is a sunk vessel. So because Malacca, they have this penambakan tanah, they want to extend the land, so at the sea, by the sea. So since it's a sunk vessel, they wanted to evaluate whether the structure is worth enough to be recovered. Because if they just let it be there, they just get a compound of 1 million. They will get a 1 million compound. So what they asked us is evaluate it. You evaluate and give us a right indication whether this particular solution is feasible or not, and whether the structure is still recoverable or not. Then we give a report that 70% of the structure is still can be recovered and has a second life. So they thought of, okay, why don't we just recover it? And this is one of the solutions that we did. And this is our client base. Okay, like how I say, oil and gas industry. We have partnered with Gold Palm Petroleum in Kuwait, oil and gas industry. Marine structure inspections, Aquaspace. They fly the they fly the drone and so on, and then also ROVs, and they give us a 3D model, and then we start to do the analysis. But I wish to share that we have started to look into oceanography for this particular solution as well, and they have approached us to train more of their data, so that we can build an AI solution for oceanography as well. Solar industry, we are happy to share that Sirim is one of our client, Matan also as well, and yeah, ETHM we did as a pilot project. Now for entire ETHM we are flying regularly, so that we can give them a report of energy loss and so on, and Gading Kencana bulk industry. Interestingly, like how I said, we are also into agri-tech with the same AI model, because for us it is just a data. Okay, same procedure. We get the data, we analyze, we identify the chlorophyll deposition of the plant, and we start to do prediction. So flow is same. And these are the two drone companies, VS Streams with Revolution and Eagle Eye Technologies, that have started to use our platform for their inspections, for their inspection services. Okay. Any questions so far? No? Yes?
Doctor, can I just ask here, because typing
Yeah.
is okay. Since you are doing a lot of things related to solar, right? One of the concern is overheating that can cause fire.
Okay.
Okay, is there any way that this AI predictive system can sort of setting a threshold and give a warning where it's about to start burning, things like that, because this is a big thing that can help to maintain the maintenance more efficiently. Before the fire itself, is there any way that we can alert the workers there, this is bad, we need to replace this, or we need to do something with this? Thank you.
Thanks for the question. Very interesting question, and I wish to share how we did reporting for that, and how we do the analysis for solar. So give me like 2 minutes so that I can open my my report. Just a moment. Okay. This one. I can show this report is because this is a demo report that we fly for this particular company at Seremban, Jembo, where they wanted to see how we are doing the reports. Okay, now, okay, this is one of the report. Okay, we do pre-flight and so on. Okay, now I guess this is the part that Sir is interested in. So with the thermal images that because we always, like for solar industry, we fly drones, and then with and the data that we capture is actually the uh, thermal data. Okay, so that,
Doctor,
yeah.
sorry to interrupt. Are you presenting your report?
Oh, okay. Sorry. Uh, it's not being shown, is it? Okay, just a moment. Let me share the entire screen. Entire screen. Okay. Is my screen can be seen? Yes.
Yes.
Right now you are in the your documents file.
Okay. 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 I just show this part. I show you two different reports. One is for Sirim, another one is for Jumbo one. Okay, this is a solar farm. Okay, this is a solar farm, and these are the pre-flight checklists that we always have. So this is the size of that farm. So once we identify, once we fly, what we'll do, we will go one by one. We'll go one by one. Let's say there is a difference in between the colors and so on. What we will locate is, we'll locate it as a defect, and within the defect, we'll start to do the thermal analysis. And I guess this is the point where Sir is interested to, which is, this is the temperature that we will set to give an alert that, okay, your particular regular temperature should be within okay, wait, let me see. Okay, this is the LN curve that we will look into. If any of these particular specifications has been more than what it should be, that's the point where we'll start to give an alert. But this particular client didn't ask us to set a dashboard, so we didn't. But we are able to convert this data into a dashboard so that they can locate the particular defect, and they can also start to do the mitigation plans. And also they are able to predict what is the loss power output as well with the temperature differences. So if let's say it is more than like 93.7% maximum temperature, which is within this area, I would say within this panel, this is the area that has been defected. From there, they are able to also identify what is the current output as well. So with regular flying, with a lot of regular flying, what will happen is we are able to identify what is the temperature that particular panel is currently facing and currently exposing to. From there, we are able to identify, we can able to predict the particular failure of that particular panel as well. Okay, these are the sample reports that we did for this particular company. So these are samples. So we are able to give remedial actions as well. Maximum
Okay,
temperature. So on.
thank you, Doctor.
Is there any questions on that? Hello. Hello. Am I audible? Hello.
I think you have answered Mr. Zul's
Okay.
questions.
Okay, got it. I think I have another 8 more minutes. Just go for a direct report. Sorry, just finish my presentation. Okay, so yeah, besides that, as a startup, we have like awards and so on, and we are being backed up with Google Cloud for startups, AWS startup programs, where we are currently migrating almost all our solutions into their cloud services. And for the particular structural analysis and so on, currently we are using SolidWorks because SolidWorks is able to be used in different platforms in comparison with ANSYS and so on, because the API integrations is quite easy for SolidWorks. That's why we are currently using SolidWorks. I would say the FEA engine behind the analysis is actually SolidWorks, and we are being funded by MTDC, Cradle, and Launchx and so on. And we have okay, call to action. Actually, we are looking for investments. So if there's any VCs that looking for us, looking into perspective of investing, they can approach us. But beyond on that, we are looking for partners, companies to work together so that we can get the particular solution even more smarter. Because I guess all of us have used ChatGPT. So the more you ask questions, the more data is being given to the ChatGPT, the smarter the AI works. That's the same concept that we're looking into. The more data sets that we get, the smarter we build the AI, and the precisions will be there. At this point of time, we have almost 75% of that particular solution, which is able to identify the defects and do the analysis. Now we want to push almost 85%. That's the target that we have set for this year. And by next year, it should achieve at least 95%. Okay? And to engage with the government-backed industrial automation projects, collaborate with smart infrastructure initiative stakeholders. If there's a lot of any clients that is coming from real estate properties who wants to evaluate the site before selling to your clients, that kind of services also we are able to provide, and we wish to collaborate as well. And now, of course, global expansion, which we have started to look into those perspectives. And these are the list of journals. If anyone is interested to read through our the journal that I did, can go through as well. These are a list of it. And these are some invitations that has been invited for us to pitch and of course share during the technical conference and so on. Okay, so this with NodeCom on board, we are expecting to achieve 6 different SDG goals. So since most industries have started to look into sustainable development goals, so we have started to engage with carbon emissions as well as part of these solutions. Okay. With that, I guess I'm wrapping up. I think I have a video if I'm not mistaken. Oh no. Yeah, that's the final one. So with that, thank you so much. I guess so. I have given a brief introduction, overview of our solution. So we are looking forward to work together with anyone who's interested. I can even share the slides to you. You guys can go through, and then we wish to collaborate as well. Thank you.
Okay, thank you, Doctor. Give me a moment. Okay, ladies and gentlemen, now that we have heard some insights from Dr. Shaktivell on the capability of NodeCom. Now, so if you have, we still open some floors for the audience to ask for questions, and in the meantime, while waiting, if waiting for the audience to send up the question, Doctor, I actually have a question for you.
Yeah.
First question is, how does this node.com differ from the conventional inspection and maintenance methods in construction?
Like how I said earlier during the early introduction, we are not just focusing on maintenance and maintenance only, but we are focusing in predictions and prescriptions, which I would say in an overview, you are actually reducing the reliance, sorry, the your dependency of having 3 to 4 consultants to by having Notcom, you can streamline it to be having one consultant, which is your Notcom. But we are not giving an assurance that that is the ultimate one. So we are providing both predictive and prescriptive maintenance concept within the same single window. So the client will have an enhanced version of their maintenance already there. In comparison with existing solution, where it is highly driven with predictive maintenance, they can able to predict, schedule the maintenance and so on. But prescribing in accordance to the problem and the predictions is the forte that we wanted to look into, and that is what we are building as well. And just to add on, not much solution is able to get multiple data sets streamlined within one inspections. See, for an example, the data sets that we are getting into the AI is not only related to conditions. We are using drone-based and drone-based model. We are using NDT data, sensor data, and as well historical data to be streamlined and to be done as a predictive data input for us to do the analysis.
Right. Thank you. Let me see in the chat. Still no question. Right. If there is no question, I have a second question actually in my mind. Right. So, second question is, can this node.com be applied to existing infrastructure, or is it only suitable for new construction projects?
That's a nice one. Nice question. Actually, we are not limiting ourselves to just focus on new constructions. But of course, it will give an upper hand for us to work on the new constructions, because everything is, I mean, all the data, all the plans and everything is already there, so it is easier. But we are able, like how I said, that's why we are working with AI, where we can adopt to the data that is already existing. So regardless it's old or new project, we are able to deploy this particular system within your project. And we can also look into, if it is a new project, we are also able to look into your project progress, all these things. If it is an old project or all construction site, with the project progress. So to make it very simple, technically we are able to cater your needs if it is regardless it's a new project or old project, no problem.
That's good to know. So let me check. I see a red dot. Right. So another question from Mr. Zulpami, right? Engineers may question how the AI made its prediction, especially when abrupt changes occur. Lack of explainability may lead to low confidence in AI outputs for high stakes decisions like repair timing. So how do you counter this challenge?
Yeah, actually, this is the current challenge that we are currently facing in the industry, because there's a lot of penalizations having around. Okay, like how we are countering it is we are just trying to get the existing solutions which is in accordance to the standards that has already been set for that particular job. For an example, since it is a general question, I would like to make it specific for oil and gas first, because oil and gas, in comparison with construction, oil and gas has more, a lot of threshold, a lot of avenues that we have to look into. So how we are trying to match it is we are trying to get the analysis to be in accordance to the API standards that is already there. So when these particular solutions are in accordance to the standards that is already there in the normal practice, that's where the engineers has the acceptance of these particular solutions to be there. But like how I said, the AI is still the AI ecosystem is still in a very early stage. Now, we are not alleviating or eliminating the entire process, saying that, okay, now AI is there, so you can be highly dependent on AI, no need to go for consultant. Actually, we are trying to enhance the existing maintenance workflow by providing AI into the ecosystem. So if that particular AI is in accordance to the standards that is already in the norm, in the practice, and we enhance their particular process flow, that's where we counter the challenge of having our solution into the market.
Right. Thank you for your answer, and also thank you, Mr. Zulfami, for your question. So, in wrapping up to this session, we have been treated to a session that was both informative and inspiring. A special thank you goes to our speaker today for sharing his valuable insights. Would you like to do an ending remark, Doctor?
Yeah, just to wrap up, like how I said, this AI, don't, I always put this as a final note of my session. Don't be, uh, you know, don't have an anxiety on AI solutions. Actually, AI is there to enhance any of your industry's need. We are just there to help you, not to alleviate things. So consider us as a partners instead of, having an anxiety on this. Point one, point two, we are looking forward to work with a lot of individuals and corporates as well to enhance the AI model and so on. So with that, thank you so much. Looking forward to collaborate with all of you. Thank you.
Okay, so additionally, we have a moment ahead as we present a certificate of appreciation to Dr. Shaktivell for his contribution as to for today's speaker. So, Doctor, this is your certificate. Of course, I will email it to you, right? Okay. Now let's next, ladies and gentlemen, before we conclude our webinar, let's capture this special moment with a virtual group photo. With that, I invite all the attendees to open your camera.